Hi, kids. All right, so we have a graph. It is force on this side, measured in newtons. Displacement on this side, measured in meters. It says the spring is stretched and the data is graphed, so there's my data. Love it. Determine the work done when you stretch the spring 0.4 meters. And then how much energy would be stored in the spring if the stretch was 0.75 meters, okay? Remember, anytime you get a graph, you need to go look at three things. You need to look at the graph. Okay, so let's look at the graph. All right, force, displacement. Let's see. Force, oh yeah, this might have something to do with work because, remember force and, F and D, okay? But you need to look at the slope, okay? The slope would be rise over run. F over this. Oh, wait a second. I remember doing something with that. That was considered our spring constant. Remember, this was Hooke's law, which is this. So I end up with K equals F over X. So rise over run, which is 9 newtons divided by 0.4 meters. And you get 22.5 newtons per meter. Okay. What this means is if this spring was stretched 1 meter, it would require 22.5 newtons. Okay, which is actually this is a pretty weak spring. Okay, because 1 meter is pretty far, and that's not that much force. But anyway, that's okay. But that would be our spring constant. Remember, but that's the slope. But then if you think about okay, so if I want to find the work, let's say you didn't remember what the equation was, and you go okay, well so. If I think about this, if I want to do, let's look at the area of this. The area would be, it's triangle, so 1/2 F times X, so that's like F times D. Oh, that's my work, yes! So, but if you think, because again, you can't use this formula, because this formula only works if you have constant force, and we don't. It's changing. Okay, so I don't have constant force, so I can't use that. But if I find my area, it's going to work. So my area would be 1/2 base times height, so 0.4 meters and 9 newtons. And if you remember, a newton meter is a joule, so hence there's my work, okay? Again, this is where just understanding units and understanding what that is, you can figure out a lot of stuff, very important come AP test time. But if I go 9 times 0.4 times 0.5, I get work is 1.8 joules. Well, if you remember, okay, another way you could have done this is anytime you do work, you're either adding energy to a system or taking energy away. So the work is the change in the energy. So another way, if you remembered the equation for energy stored in this spring, it's this. Well, if I did that same thing, if I plug this in, 1/2 K, which is 22.5 times X, which is 0.4 squared, lo and behold, you get 1.8 joules. Hooray, physics works. Okay, but I did the first part. Now if I want to do the second part of it, I'm going to end up using this part, so I'll use the 0.75. And if you do the math, you get 0.75 squared times 22.5 times 0.5, 6.33 joules of energy. Okay, and there you have it. Okay, the one thing I do want to mention to you guys, let's say that this was doubled. Okay, so I went from this to 0.8. There could be a question that says, well, what happens to the energy? Is the energy doubled? And you're hopefully you guys would say, no, the energy is not doubled. And you can kind of see it even here, that going from here to here, I didn't even double this, it's more than doubled. The reason it's more than doubled is because it's a square relationship. So if this was 0.4 and this was 0.8, okay, then it would actually be 4 times greater because it's a square relationship. 2 squared is 4. But just keep that in mind. All right, bye, kids.